Between February 22nd and February 28th, 2026, the artificial intelligence landscape, it fundamentally shifted. I mean, we are looking at a historic, record-breaking $110 billion funding round.
Right, it's unprecedented.
Yeah, and on top of that, we are tracking highly classified defense contracts, the quiet but massive launch of GPT 5.4, and these major tectonic shifts in how we even measure what AI can do. So welcome to the Deep Dives. We are thrilled you're here with us today.
Absolutely.
If you've been feeling overwhelmed by the sheer volume of news coming out of OpenAI recently, well, you are exactly where you need to be. Our mission today is simple. We are going to cut through that massive mountain of press releases, research papers, and status updates, and we are going to extract the exact nuggets of insight you need to stay ahead of the curve. No fluff, just the most critical takeaways tailored directly for you.
And it is vital that we look at the specific week in isolation to really understand where the technology is heading. We are witnessing OpenAI's definitive transition here. They are no longer just a specialized research laboratory.
Right, the vibe has totally changed.
Exactly. The events of late February represent their evolution into an entity that provides foundational global digital infrastructure. I mean, the sheer scale of what happened this week changes the trajectory of the entire tech industry. And it's going to change how you interact with computers on a daily basis.
Okay, let's unpack this, starting with what's happening in the research labs and how we even evaluate these systems in the first place. Because on February 23rd, OpenAI Research dropped a bombshell about something called SWE-bench Verified. Now, I was under the impression that SWE-bench was the absolute gold standard for measuring how well an AI can write code. But it sounds like they are completely abandoning it.
You're right, it was the gold standard. Every time a new model dropped from any company, the creators would point to their SWE-bench score to prove how good their AI was at software engineering. But OpenAI published an audit revealing that they are moving to a new standard called SWE-bench Pro, primarily because the old system is suffering from severe contamination.
Contamination, like the model already saw the answers.
Partly that, but worse. They audited a subset of the test problems and found that an astonishing 59.4% of them had fundamentally flawed tests.
Wait, almost 60%. So the benchmark was actually rejecting perfectly correct code.
Yes. The tests themselves were broken. And this raises an incredibly important question for the entire industry. When you are building frontier models, the most advanced AI systems on the planet, and nearly 60% of your test answers are essentially wrongly grading the AI, you have hit a measurement ceiling.
Wow.
Frontier models have outgrown our current ability to test them accurately. OpenAI is signaling that to build smarter systems, we desperately need more robust ways to measure them. Otherwise, we won't even know when we've achieved a breakthrough.
To me, that is like trying to weigh gold on a broken scale. You can't trust the value if the tool doing the measuring is structurally compromised. And speaking of building those smarter next-generation systems, they are expanding their physical footprint to do it. Reuters reported on February 26th that OpenAI is establishing London as its largest research hub outside the United States.
Which makes a lot of sense when you look at the global talent map. London gives them direct access to a completely different, incredibly rich talent pool and a world-class university ecosystem like Oxford and Cambridge.
Yeah, you can't just hire everyone in California.
Precisely. To push the boundaries of core AI system development, you need the absolute best minds in the world, and frankly, you just cannot contain all of them in Silicon Valley. It's a strategic play for human capital.
But they aren't just doing theoretical research in these hubs. They're getting very practical very quickly. On that same day, February 26th, OpenAI announced a partnership with the Pacific Northwest National Laboratory, or PNNL, which is part of the Department of Energy.
Right.
They launched something called Draft NEPA Bench. Now, NEPA stands for the National Environmental Policy Act. These are those massive, thousands of pages long environmental impact reports the government does before building infrastructure. OpenAI is taking coding agents, specifically Codex CLI, and testing them on these high-stakes, document-heavy workflows across 18 different federal agencies.
And just to clarify for you listening, a CLI is a command line interface. It means the AI isn't just chatting in a web browser. It is integrated directly into the text-based terminal where developers and data scientists actually do their heavy lifting.
Right in the code.
Exactly. What is fascinating here is the concrete application. Bureaucracy and federal permitting are notoriously slow. But this benchmark targets up to a 15% reduction in drafting time.
Which translates to what in the real world?
They're looking at saving between 1 to 5 hours per subsection in critical government operations. This is a massive proof of concept for AI in the real world. They are taking an agentic AI, an AI that can take actions on its own, and trusting it to navigate highly regulated, incredibly dense public sector workflows.
That's huge.
It really is.
Yeah.
If they can speed up federal permitting by 15%, that means bridges, power plants, and infrastructure get built years faster.
From federal bureaucrats to everyday users, the tools themselves took a massive leap forward this week. On February 28th, OpenAI launched GPT 5.4. This is a highly efficient frontier model, but the feature that immediately caught my eye is this new interruptible thinking mode.
Oh, yeah.
You can actually steer the model mid-response. I can't tell you how many times I've watched an AI confidently type out 3 paragraphs of absolute garbage while I frantically mash the stop generating button.
It is a universal experience at this point, and that steerability is a true game changer for complex workflows. In the past, if a model started generating a long, detailed response and got a premise wrong in the first paragraph, you had to wait for it to finish or cancel it entirely and start over from scratch.
Which is so frustrating.
Exactly. With GPT 5.4, that interruptible thinking gives you unprecedented control. It's like having a brilliant coworker who sometimes goes down the wrong rabbit hole, and now you can just tap them on the shoulder, stop them, and redirect them before they waste time.
And it doesn't just save time, it saves computing power, right? The release noted that it utilizes significantly fewer tokens to solve problems. For anyone not deeply in the weeds, think of tokens like the basic units of data the AI reads and writes, almost like syllables in a word. Every token costs computing power, which costs money.
Exactly right. So when GPT 5.4 uses fewer tokens because you can steer it efficiently, that directly translates to lower API costs for developers and businesses. Add to that the fact that its deep research capabilities have been vastly improved, allowing it to maintain context over hundreds of documents without losing the thread, and you have a much more capable economical engine.
And speaking of developers, the platform they use to build all these apps got a massive overhaul this week. Between the 23rd and the 28th, OpenAI rolled out major updates to their API developer platform. They introduced GPT 5.3-Codex. They rolled out GPT Real-Time 1.5, which boosted transcription accuracy by 10.23%.
That's a very specific but very significant jump.
Yeah. But the craziest part to me is that they extended the deep research API timeouts to 3,600 seconds. That is a full uninterrupted hour. Why is a 1-hour timeout such a big deal?
Because it completely changes how software is built. Previously, developers running highly complex, compute-intensive reasoning tasks had to build all sorts of orchestration workarounds. If a query took more than a few minutes, the connection would time out and drop.
Oh, so the code would just break.
Right. Developers had to build background queues, webhooks, and complex pinging systems just to keep the connection alive while the AI thought.
So they were basically constantly tapping the server saying, "Are you still there? Are you still thinking?"
Yes, which is incredibly inefficient. By extending the timeout to 3,600 seconds, OpenAI is removing a massive bottleneck. You can now execute hour-long deep research tasks natively. You open the connection, ask the model to analyze 100 legal documents, and you just wait.
That's wild.
Combine that with the low-latency voice apps enabled by that real-time 1.5 update, and developers are being given the tools to build incredibly sophisticated long-running applications without the traditional engineering friction.
That theme of removing friction brings us right into the Codex and Figma integration announced on the 26th. Over 1 million people use Codex every week. Now, through a new Figma MCP server integration, there is a seamless code-to-design round-trip workflow. Let's break that down, starting with MCP. That stands for Model Context Protocol, right?
It does. Think of an MCP server as a highly secure, standardized bridge. It allows the AI to securely reach into your specific workspace, in this case Figma, which is what designers use to draw up websites and apps and read or edit the files directly.
Which solves a massive headache.
Yeah.
If you've ever worked in software development, you know the handoff between the design team drawing the app and the engineering team coding the app is a historic battleground. Things always get lost in translation.
It is a major pain point. But by creating these agentic build loops, Codex can now directly interact with Figma designs. You aren't just generating code in a vacuum, you are generating code that inherently understands, reads, and iterates on the visual design layer.
So it's looking at the picture and writing the code to match.
Exactly. The AI looks at the design, writes the code, checks it against the design, and adjusts. It collapses the distance between drawing an idea and actually building it.
Okay, so let's take a step back and look at the physical reality of all this. To power millions of users running hour-long API calls, deep research models analyzing hundreds of documents, and agentic build loops, you hit a physical wall. You need power.
A lot of it.
Yeah, and that explains the massive, mind-blowing deal announced on February 27th. OpenAI expanded their AWS partnership by $100 billion over the next 8 years. And part of that is a commitment to consume roughly 2 gigawatts of Amazon's custom Trainium compute capacity. What does 2 gigawatts even look like in the real world?
To put that scale into perspective, 2 gigawatts is roughly the power output of 2 large nuclear reactors.
2 nuclear reactors. For AI.
Yes. It is enough electricity to power a major city, or roughly 1.5 million homes. This deal is not just about renting a few extra servers in the cloud. This is about OpenAI securing the physical energy grid and the dedicated custom silicon required for the next generation of training.
And it's notable that they are committing to Amazon's Trainium chips, right? Because up until now, the narrative has been all about NVIDIA GPUs.
That is a crucial detail. By heavily investing in Amazon's custom Trainium silicon, OpenAI is massively scaling their dedicated capacity beyond standard NVIDIA hardware. They are diversifying their supply chain. They are ensuring long-term hardware and energy availability for the path toward artificial general intelligence, because right now, energy and silicon are the absolute bottlenecks to progress.
Now, when you build a system that commands 2 gigawatts of power and the intelligence to parse federal regulations, the military is going to take notice. We are moving into a highly sensitive area here regarding national security. And to be clear to you, our listener, we are looking purely at the technical architecture and factual parameters outlined in OpenAI's recent posts, without taking any stance on the politics of military AI.
Right, strictly the technical guardrails.
Exactly. So, just looking at those facts, on February 28th, OpenAI finalized an agreement with the Pentagon for classified deployments. What exactly are the rules of engagement here?
OpenAI established very strict, technically enforceable red lines for this classified deployment. First, there's a mandate that the deployment must be cloud-only. This means the military cannot take the model offline onto local, isolated servers where OpenAI can't see it.
Okay, so they maintain visibility.
Yes. Second, there's a strict ban on using the AI for mass domestic surveillance of U.S. persons. And third, there's a total ban on the AI independently directing autonomous weapons.
Right, so they aren't just handing over a hard drive and asking them to sign a promise to behave.
No, and that is what sets a high salience precedent for national security AI. By forcing a cloud-only deployment and requiring cleared OpenAI personnel to remain in the loop, they are relying on enforceable technical architecture.
Meaning they can literally pull the plug.
Exactly. If those red lines are crossed, OpenAI physically retains the ability to cut access. It's a fundamental shift from trust-based written policy to architecturally enforced oversight.
And they're applying that same level of scrutiny to personal and systemic safety as well. Between February 25th and 27th, OpenAI released a threat report. It detailed how malicious actors don't just use AI in a vacuum, but use it as one part of a larger traditional cyber attack chain.
Which is a very sophisticated view of the threat landscape.
Yeah, but simultaneously, they launched multi-turn evaluation methodologies designed with real clinicians to help the AI better support users who are in emotional distress. It feels like they're fighting on 2 completely different fronts here.
Because they are. This is a perfect illustration of their dual-front safety strategy. On one hand, you have complex geopolitical cyber threats that require mapping out massive attack vectors. On the other hand, you have individual, human-level safety. People are turning to ChatGPT in moments of profound distress.
Which requires a totally different kind of safety net.
Exactly. By treating mental health as a core, measurable safety domain and designing these multi-turn evaluations, OpenAI acknowledges that safety isn't just about a single safe reply. The model has to respond appropriately over the course of a long emotional conversation.
But doing all of this at once, scaling globally, running hours-long queries, integrating with Figma, monitoring cyber threats, it comes with massive growing pains. During the same week, the OpenAI status page read like a roller coaster.
It really did.
There were multiple service interruptions. ChatGPT free users saw degraded availability, Codex had elevated error rates, and even business and enterprise tiers saw their artifact generation completely fail for a period.
Which highlights an unavoidable reality, and that is operational fragility. As global dependency on OpenAI deepens when businesses, developers, and everyday users are relying on these models constantly, the immense scaling pressures on their infrastructure become incredibly visible. When you are the foundational layer, an hour of downtime doesn't just mean a website won't load. It means millions of workflows globally grind to a halt.
And fixing that fragility, building those 2-gigawatt data centers and hiring top talent in London requires capital,
Oh?
an astronomical amount of it. Which brings us to the biggest financial news of the decade. On February 27th, OpenAI announced a historic $110 billion funding round.
The numbers are just staggering.
They really are. That values the company at $730 billion pre-money. The round was led by a $50 billion investment from Amazon, $30 billion from NVIDIA, and $30 billion from SoftBank. And buried in that announcement, they casually dropped that ChatGPT now has 900 million weekly active users.
Let's contextualize those numbers. 900 million weekly users is nearly 1 in 8 people on Earth interacting with the system every single week. And a $730 billion valuation makes them larger than the GDP of many developed nations.
It's basically a nation-state at this point.
This funding round represents unprecedented capital formation. To dominate the global frontier AI market, you need sheer financial firepower. This $110 billion guarantees OpenAI the runway to outbuild, outtrain, and outcompute virtually any competitor on Earth.
Okay, but this massive influx of cash from Amazon creates a really fascinating technical dynamic because OpenAI has historically been heavily tied to Microsoft. But Amazon just handed them $50 billion. So on February 27th, OpenAI launched something called a stateful runtime environment for agents exclusively in Amazon Bedrock.
Right.
But at the exact same time, OpenAI and Microsoft issued a joint statement reaffirming that Microsoft Azure remains the exclusive host for stateless APIs. Help us unpack this. What is the difference between stateless and stateful?
The easiest way to understand this is to think of a stateless API like a vending machine. You walk up, put in a coin, press a button, and get a soda. The machine doesn't remember you tomorrow. It doesn't know what you ordered last week. It just handles that single, isolated transaction.
Okay, so that's the stateless side.
Exactly. That is what Microsoft Azure is retaining exclusive rights to the massive volume of traditional transactional queries.
Okay, so the vending machine stays with Microsoft. What about the stateful environment moving to Amazon?
A stateful agent is like hiring an executive assistant. They remember what you talked about yesterday, they know your long-term preferences, and they can execute complex, multi-step tasks over days or weeks because they retain a memory of the state of your ongoing workflow.
That is brilliant maneuvering. Persistent, memory-driven agent workloads are now going to run natively on AWS Bedrock, while the quick, single-turn transactions remain locked to Microsoft Azure.
Yes, it allows OpenAI to leverage the massive cloud infrastructure of both tech giants without technically violating their existing exclusivity agreement. It's a masterclass in corporate strategy. And to manage all this corporate integration, they are heavily shifting their internal structure. Also this week, OpenAI appointed Arvind K.C. as their new Chief People Officer to manage this rapid global scaling. And they launched Frontier Alliances, which are formal partnerships with the biggest legacy consulting firms in the world: BCG, McKinsey, Accenture, and Capgemini.
Right, they aren't just selling to developers anymore, they're selling to the boardrooms of the Fortune 500.
Exactly.
Appointing a high-level chief people officer and partnering with legacy enterprise consultancies signals OpenAI's definitive shift. They are no longer just a specialized research lab building cool tech demos. They are now a mature, enterprise-grade platform. By utilizing firms like McKinsey and Accenture, OpenAI is equipping itself to actively overhaul global corporate workflows. They are integrating directly into the arteries of the global economy. So, synthesizing all of these developments, from the broken benchmarks and the gigawatts of power to the defense contracts, the massive funding, and the shift to stateful assistance, what does this all mean for you, the person listening right now? How does this historic week actually change your day-to-day?
If we pull all these threads together, the ultimate takeaway is that the era of AI as a simple chat box you visit occasionally is completely over. The transition from experimental stateless chat interfaces to persistent, stateful agents living on AWS means the digital tools you use for work are about to have long-term memory.
They're going to know you.
Yes. Combine that with GPT 5.4's interruptible steerability, and these models will soon be seamlessly integrated into your daily digital environment. They will remember your ongoing projects, they will execute multi-hour research tasks in the background without timing out, and they will become active, collaborative partners in your workflow rather than just reactive tools you ping for quick answers.
It really is a complete paradigm shift in human-computer interaction. And that leaves me with one final thought I want you to mull over after we wrap up here today. Between the 900 million weekly users, the multi-billion-dollar defense contracts with cryptographically enforced red lines, and the processing power of entire physical power grids being dedicated to training these systems, what happens to society when an AI model stops being just a tool you log into and quietly becomes the invisible infrastructure running the internet itself?
It's the question of the decade.
Thank you so much for joining us for this deep dive. We hope it helps you cut through the noise and capture the insights that truly matter. Stay curious, and we'll see you next time.